In this example, we are going to calculate the angular momentum and kinetic energy of this plate. You may notice that the plate is welded to a rotating shaft at 45 degrees angle, and the shaft rotates at angular speed of 20 pi radians per second. This problem is a three-dimensional one. So a good start is to set up an appropriate XYZ coordinate system. This coordinate system will help us define all values and elements, especially vector quantities. And it will be easier to deal with these vectors over a correctly installed coordinate system. Some information are needed to solve this problem, such as the dimensions of the plate. And here we have a plate of 40 centimeters length and 20 centimeters width. Notice how the plate is welded at 45 degrees. And this will make the problem a little bit tricky. So before we work with it, let's work with another simple problem first. In this system, the plate is welded vertically to the shaft. So finding the angular momentum is very easy. All we need to do is to find the angular velocity vector, and then find the moment of inertia of the plate. Notice that the plate follows the shaft's rotation, so there is only one omega component on the z-axis. Knowing the mass and dimensions of the plate, we can apply the direct formulas of moment of inertia of plates. And finally, applying all found values directly in the angular momentum and kinetic energy formulas. Notice that the angular momentum is a vector quantity, while the kinetic energy is a scalar quantity. And let's go back to our original question with the inclined welded plate. And here comes the tricky part. We will create a new coordinate system, and rotate it 45 degrees to fit with the plate. And let's also pick a new names to these new coordinates. We name them x dash, y dash, and z dash. As you can see, x-axis does not play any action here, so we can hide it for now. According to the new coordinate system, the shaft rotates between z-axis and y-axis, so we can break it to its y- and z- components. Now we will rebuild the omega vector. Notice that now we have two components, j- component and k- component. We can also use the same values we just found for moments of inertia, because when we rotated the whole system, the plate has become horizontal, so the inertia values can be applied. Now we can use the angular momentum formula and apply all values we found. The angular momentum will be calculated on the new coordinate system, named by x dash y dash z dash. And now, we will have to go back to the original coordinate system. And to do this, we need to rotate the system back to its original orientation. And finally, we calculate the kinetic energy of this system. The main idea of the problem was to find an easy way to redefine the components by orienting them using an auxiliary coordinate system, doing the calculations, and then reorient the components back to their original position.